Good afternoon, friends. Welcome to 360DigiTMG. So, our today's topic of webinar is PyTorch in production, building efficient workflows. So, here we are going to understand about the architecture and the framework of PyTorch. Okay. So, here we are having data layer. Okay. So, data layer is nothing but here we are going to use feature store, data storage, or any type of databases. Okay, so what will be there in the feature store means it will be useful for sharing and reusing the pre-computed features like timestamps, embeddings, bucketized fields across training and survey. Likewise, for data storage and databases, we can have a raw tables in the form of SQL, NoSQL, data lakes, S3. Okay, it can be in the streaming sources like Kafka. Okay, so here every production models with chart will have their reliable data. Okay, so here we will have a different types of data sources. Some can have store a data loaders which is hooked in Kafka. Okay, so some will use a pandas data sets. Okay, for importing and data set from there. Okay, so a best practice is the versions your raw data snapshots, tag them with timestamp or a get hash and track the data drift pipeline from there. Okay. Then there comes the data pre-processing or data processing. Okay. Once we'll get a data from various data sources or feature sources, we will go to a processing here. Within a processing layer, we are having an offline processing or an online feature logic processing. So what is there in the online processing? So here we will have a batch pipeline in Spark, Airflow, or a Databricks, which will produce a training ready tensors. Okay, if the data is very big, we will use this pipelines in Spark, Airflow, or Databricks. Online feature logics. Like here, we will have a microservices or serverless functions for the fly feature computations. For batch job, we can use this Apache Spark or Airflow DAG that reads from your feature stores, which will apply and transforms like scaling or embeddings. In PyTorch, you will wrap these in custom dataset classes. Okay, custom dataset classes, implementing get items or something like that to load and pre-process the batches. If you need real-time features, you can use this. Okay, the logic of using the real-time features. And then there comes the model development. In model development phase, we are having training and experimentation. We will going to train our data set on a training site and we will going to check whether the data set is overfitting or underfitting or a right fit by using a validation or a testing data set. Okay, so here in the training and experimentation part, we are going to use our PyTorch framework. Okay, for iterative experimentation, here also we will have our hyperparameter tuning. Okay, multiple hyperparameter tuning techniques we can use like integrating Optona or a retune. Likewise, we will have multiple hyperparameter tunings for increasing the accuracy of this particular model. Then there is validation and testing. By splitting a data set, we will check whether this data set is biased towards certain class or not. So whether it is a right fit or not. For that, we are going to check on the validation or a training data set. After training the data set, we will going towards the model management. Within our model management here, we can have a machine learning flow, fake marker, model registry, or a custom solutions. Based upon that, we can use this particular model registry. Likewise, versioning. Versioning is also one more thing. We will tag an artifact We will have a model weights, code, environments. Likewise, we will have multiple semantic versions, wherein there will be having a metadata, which will attach a metrics, data snapshot IDs, and the Docker image hashes. Once you have identified a candidate, you will need to place to store it. A model registry like a machine learning flow or a AWS stake makers. Likewise, there will be multiple things for storing this particular pipeline. Okay, once you have got that, okay, my data set, my model is a right fit model. We are going to store that particular model by using various multiple libraries. Okay. And after this, there will be a deployment or a serving phase. Okay. So here in the deployment part, we can use multiple tools for this. We can have a Flask application, Fast API, or multiple different tools like Torch Serve. There are multiple interferences from where we can use any of them. Okay. Then we will have an authority and security. So here we can use a JWT tokens, network policies. Okay. Multiple things we can use and we can apply this. Then there is a CI/CD pipeline, which can be integrate itself with a GitHub Actions, Jenkins pipeline to build a Docker images, run this test and deploy to Kubernetes or any other serverless platform. Okay, for serving the PyTorch model, TorchServe provides a trunky solutions like defining a handler, bundle your model, and scale like Kubernetes or any other ECG platform, EC2 platforms. If you need custom logics, you can use a pre or a post training processing. You can embed the PyTorch in a Flask or a Fast API framework or application and secure your endpoints with multiple like Postman or other things you can use for securing whether it is giving you the response or not. Okay, all this should be wired into a CI/CD pipelines. Okay, which will build a Docker image with models, which will run the integration test and it will hit on the staging endpoint itself. Okay, and then we can use it for deployment on a production side. Okay, so likewise, we can use this particular PyTorch framework for different use cases. Likewise, at the end, after deploying in the production side, we can use it for monitoring, continuous monitoring and maintenance. Okay, so monitoring and logging. Here, in the logging phase, logging means capturing the input, output and latencies. Like pushing a CloudWatch, continuously having a CloudWatch. Then matrix and alarming. Okay, so here we will track throughout the error rates and sources used. What is the source, what source we are using, what resources we are using likewise. And there will be one concept called as data drift or a concept drift. Okay, data drift and concept drift is it is generally useful for monitoring and maintenance part, whether our data is going to is drifting or our concept is going to drift. So comparing our live feature distribution to training, we will alert this on divergence. Whether this point is having a divergence, whether this point is having a divergence, because of this, the issue is there. Likewise, this crucially, we have to monitor the data drift part. Okay. Likewise, we can use it continuously. Monitoring we can do continuously for. Okay. So we have understood about how we can take a data set. Okay, how we can integrate that data set with multiple data pre-processing steps, how we can use this particular model and by dividing the model into, splitting the model into training, validation and test. We will going to train our model into a training side and we are going to validate our model or check our model whether it is a right fit or not by using a validation or a testing data. Okay, once we have finalized our model, we can use it for storing and we can use it for deploying this particular model. Once our model is right fit, we can use that particular model for deployment on different pieces like Flask API, Fast API, Flask, or multiple like Streamlit, simple Streamlit application, or multiple different things we can use for creating the application. Then continuously monitoring and maintenance part we have to do. Here inside of this, for storing this, for building this model and for storing this model and for the deployment of this particular model, we can use the CI/CD tools, CI/CD pipelines. Okay. So this is when it comes to theory part. Let's see a practical implementation of this. So here we have used our application, Flask API application. We have used Flask application. And here you can see we are using our data set, which is a custom data set. Okay. So we are using this data set directly from our torch.utilities.data. We are directly importing this data set. Okay. And we are using this multiple, since we are using a PyTorch framework, we are importing PyTorch and we are importing all these libraries. Optimization tools, neural networks, torch, request. So there are multiple libraries that we are installing and importing as well. So this is our data set which we are taking. Randomly, we can take any data from whatever the, here we have taken a data which is already present in our torch.utilities within the folder called as data. Okay, so we are using this particular data set. We are building our model here. This is how we are building a very small model. Here we are only having one activation function layer, which is a ReLU activation function. And this is the model training from the scratch we are doing. You can customize your model on your own. Okay. And then we are just storing this particular model, saving this particular model. First, we have to run this model. So we are running 5 epochs now. Okay. And we are going to save this particular model. Okay. Once we have saved this model, we can use it for deployment part. Okay. So for deployment, we are using 2 API. Here we are already integrating this with a Flask application, right? So here we are using this model path and we are using this particularly 2 application routes. First, we are using as for index and second is for predicting the outcome. So 2 user-defined functions we are using and we are using it for predicting the outcomes. Okay. And this function, this 5th one, is for initializing our model. Okay. For initializing our application, we need to write this. Okay. And once we have trained 5 epochs, we are running this epoch, we are integrating with our Flask application, wherein we have taken 2 apps, index and the post one. So this is how we are going to post. Okay, once we will run this, you can see our application is still running here and we will get one name called as this is running. Okay, so here you can see whether it is. Okay, you can see here the PyTorch model server is up with a name predict with a JSON file. Okay, once we will add some terms more here, it will going to predict this. So our Flask application is running. So this is how we can do a deployment. So here we have understood how to take the data set, user-defined data set we have taken. We have created the model. From the scratch, we have created the model. Okay, we haven't applied any hyperparameter tuning here, but we can apply. Okay, for increasing the accuracy, we can apply any model.compile. We can add or optimizers like Adam, AdaBoost, AdaDelta. Likewise, we can apply multiple hyperparameters as well. Then we are training this particular model, saving this particular model, and we are integrating this model with the Flask application. Okay, so this is what our PyTorch framework we are doing. Okay, so I hope this is understood. So this is it from my side for today. We are going to understand next topic on next Monday. Okay, so this is our contact details. You can contact us. Okay, you can mail us also. Okay, once you will contact us, our salesperson will going to call. Okay, or otherwise you can connect with us on LinkedIn or Facebook or Instagram. Okay. So thank you for joining, guys. We will meet with a new topic on next Monday. Thank you. Thank you so much.